This project, known as Attention Please, will require us to turn on the press switch, and then we will tap the touch plate, and the brightness and rate at which the LED flashes will vary. You can see that it gets brighter and blinks faster, and then gets dimmer and blinks slower. This type of light may be used in stores or in retail areas or other places to get the attention of customers or bystanders. We're going to pretend that this circuit is a proximity controlled sign. After we turn on the press switch, we will slowly move the magnet toward the read switch, and the rate at which the LED flashes, as well as its brightness, is changed whenever you move the magnet toward the switch. You could pretend that the magnet approaching the read switch simulates a person walking by a proximity activated sign. And a lot of businesses have electronic signs that flash or scroll, and they may be adjustable. You could adjust the speed of the sign or the message itself. Project 112, normal heartbeat, is very simple. Simply turn on the press switch, and the LED will flash steadily, resembling a normal heartbeat. A normal heartbeat means that a person's heart is fairly healthy. Turn on the press switch, and if the LED comes on, hit the momentary switch to turn it off. Now we're going to pretend that we're sending a message in Morse code, or demonstrating Morse code. Hit the momentary switch quickly to simulate a dot, or hit the momentary switch more slowly to simulate a dash. Here's a dot, and now here's a dash. And if you tap the momentary switch in different combinations of dots and dashes, you can send a unique message. Morse code was an early form of communication, and it was the predecessor of the telephone. Turn on the press switch and hit the touch plate if the LED is not flashing, but it is, so we will hit the momentary switch and the LED will turn off. Then touch the touch plate again and the LED will flash for several seconds. This could act like a sign that flashes quickly to indicate a quick sale in a store, since it will only be on for a short period of time. Pretty neat. Turn on the press switch, and if the LED does not come on, then place the magnet on the read switch and the LED will flash. You can pretend that this is a flashing alarm light indicating that your alarm system is not yet ready to be armed in your house. You could pretend that a window or door in your house is open when the magnet is on the read switch, and that you have to shut that window or door so that the alarm will be ready. Removing the magnet simulates you doing that, and then the alarm system is ready to be armed. Project 116 is FM radio. We built this FM radio, and we are going to turn on the press switch, and you should hear sound from the speaker. The spring wire acts like an antenna. For best reception, hold the exposed end of the wire up in the air. What's more interesting, though, is that your body acts like an antenna when, in this instance, you touch the exposed pin of the spring wire with your finger. The signal might be a lot better if you do that. Now, the momentary switches are used to flip between stations. You can flip forward or backwards.
So you see that multiplier.
Now, this is not a perfect example of an FM radio, but it explains the principle of how FM radio works. FM stands for frequency modulation, as opposed to AM or amplitude modulation radio. FM radio has at least one advantage over AM radio in that its signal is often clear. However, any particular FM radio stations can only be picked up in certain areas. For Project 117, FM radio in a medium volume, we're going to turn on the press switch, and you can see that I included the lamp in the circuit, and you can still flip through the radio stations using the momentary switches. Hold the exposed end of the spring wire in the air for best radio reception, or touch the exposed pin with your finger. And note that the volume of the radio may be reduced because the lamp is acting like a resistor for the speaker. Project 118, FM radio with level meter, includes the LED instead of the incandescent lamp. I am going to turn on the press switch and hold the antenna in the air, and when there is sound, the LED will blink. It will flicker. Now, it may not seem very bright, and the sound of the radio is even lower because the LED has even more resistance than the lamp. Also, there is a drop in at least 1.5 volts across the diode in the LED module. So this is definitely not the best radio to use. Project 119, adjustable radio volume, includes the volume module, number 38. We will turn on the press switch, and now we can adjust the volume of the radio by using this knob. Turn the knob to the right to increase the volume. Hold the spring wire in the air for best reception.
But even there, certainly with the economic
and then
I don't think it's a question
turn the knob counterclockwise to decrease the volume. The volume module works because it has an adjustable resistor inside of it to vary, in this instance, how loud the sound coming from the speaker is. And the volume module increases or decreases voltage seen in the inputs in the amplifier module, which is number 14. Finally, the last project in this kit, 120, is adjustable radio volume with level meter. We will turn on the press switch, and note that both the volume module and lamp are included in this circuit. Hold the antenna up in the air, the spring wire in the air for best reception, and touch it with your finger. Touch the pin with your finger. Now you can flip through the stations using the momentary switches, and then you can adjust the volume by turning the knob on the volume module clockwise or counterclockwise. And the lamp may or may not flicker while the radio is on. It will vary according to the volume. And here they talk about how frequency modulation works. Frequency modulation means that the instantaneous frequency deviation, or defined as the difference between the instantaneous frequency and carrier frequency of the radio signal, is proportional to the voltage level of the audio signal. The FM receiver collects the radio signal over the air through the spring wire, demodulates it, or eliminates the carrier frequency to provide a baseband signal, and then uses a frequency detector to recover that audio signal. With that said, thank you so much for watching the demonstration of the projects of E-Blox Circuit Builder 120. Please stay tuned for more demonstration projects and more electronics kits.